So critical thinking is really important in linguistics, partly because linguistics covers so many aspects of thinking about language, using language, and being able to handle all sorts of different ways of studying language. So knowing how other people have ideas about language, how they analyse language, how they want to discuss language, this all can get quite complex. And criticality in our field is really about the confidence to handle that complexity.
Critical thinking is really important in physical geography and science in general because knowledge isn't a fixed thing. As we learn more and do more research, the knowledge changes, and so our students have to keep an open mind and understand the evidence as it progresses so that they can understand their discipline more deeply.
Critical thinking in mathematics involves the kind of maths that very much goes beyond applying rules and formulas or memorizing mathematical facts. It is about making connections, combining ideas and different techniques to come up with creative ways of approaching and solving problems.
Critical thinking in art and design practice is really important because it combines the two essential components for all designers and all artists, that is theory and practice. This theory-practice relationship is essential. What it does is brings together all their theoretical studies in things like design history, art history, material culture studies, and finds a context to locate them in. Critical thinking, then, is their way of examining that information in that context.
History, when you're studying it at university, when you're an academic historian or a professional historian like I am, history is about understanding what went on in the past, and to do that we need to think critically about the materials that we're working with and also about the way in which those materials have been used by other people.
The critical thinking that we encourage them to do is to say, we want to take information and analyse and interpret it rather than repeat back that information. It's this ability to take information and interpret it into lots of different contexts that enable good artists and designers. Critical thinking from this point of view is about really establishing their own independent critical thought.
Most students will spend a lot of their time engaging with sources. We divide these up into primary sources and secondary sources. Primary sources are the documents and images and so on that were produced during the historical period that you're studying. And you need to think about a lot of things to do with how they were produced and why, what was the audience, why were they produced in the first place, but also about why those things have survived for us.
I think for physical geography, fieldwork is a key aspect of the discipline. When you are in the field doing research and when students are in the field doing research, they really need to think about what's going on in the environment and where they are, and not just perhaps the data that they're collecting. For example, if they were doing a study on soil and they wanted to look at soil carbon, they would be able to take some samples of soil and analyse that and get numbers out in a lab. But that's only really one part of it. They need to understand the environment, where they are, how the land is being used and how it's been used in the past. They would need to think about the underlying geology of the area, what the important species are that are growing there, the plant species, and they need to put all that information together to understand that data that has been spat out in the lab.
So when mathematicians look at data from traffic, they find all kinds of patterns, and the students will try and describe these patterns in a mathematical way and translating them into a mathematical language. Where they would start the project is just thinking about their own driving and how they could draw out the essentials of their own driving and describe them in the mathematical language. They might then go on to look at other questions, for example, how phantom jams develop. So these are traffic jams that seem to come out of nowhere for no apparent reason. And studying the mathematical equations behind how traffic moves, they might be able to find an answer. They might then move on to other questions, such as whether, for example, changing lanes when driving can reduce your travel time. All these things require quite advanced mathematical and critical thinking skills.
A beautiful piece of sculpture by students from 2015, Sam Judd. It's actually a bench that surrounds the tree outside the Students' Union. It's the most beautiful example of bringing together critical thinking positions around theory and practice based on a Mies van der Rohe, a very famous architect, quote that says that a chair is a very difficult thing. This piece of work is about that difficulty of establishing that the simplest things can be the most complicated.
And so by the time you get to the end of a degree, you're doing an independent research project where the question has to be your own, the sources you find have to be your own, and the way you write up your argument, your thesis, your dissertation is going to be all about showing that you understand the what, but you can demonstrate why, and you can demonstrate the implications of the particular angle you've chosen. All of that requires a lot of independent thinking.